young women students who will be inspired by her journey as a scientist. And then she will speak the next half of her lecture on her work, especially understanding the universe in a language understandable to a diverse audience. So let me begin to introduce Professor Puspa Khare, today's speaker. Professor Puspa Khare is MSc Physics gold medalist from Indore University. She did her PhD in astrophysics from the Tata Institute of Fundamental Research, Mumbai. After retiring as a professor of physics from Utkal University in 2010, he was CSIR Emeritus Fellow at Ayuka, Pune till 2014. He has published more than 50 papers in referred journals. Professor Khare has been a visiting professor at several universities around the world, including University of Illinois, at Chicago University of South Carolina, University of Chicago, University of Osaka, etc. She has presented her work in several international conferences at Shanghai, Chicago, Columbia, and Marseilles. She was one of the 100 women scientists whose short autobiographies have been compiled by the Indian Academy of Sciences as Lilavati's daughters. She was also featured in 75 Bigyan Vidushi brought out by DST on the occasion of Azadi Ka Amrut Mahotsav. He has given innumerable lectures on popularization of astronomy. He was a member of the committee which rewrote the physics books of Standard 7 to 12 of the Maharashtra State School Board from 2017 till 2020. These books were written in English and translated to Marathi by the committee members themselves. In addition, she has translated 3 popular astronomy books written by Professor Joyant V. Narlikar from Hindi to Marathi. She, along with Ajit Khembavi, has written a book on gravitational waves in English, published by Springer International, and in Marathi. The Marathi book begged the prize for science books given by Maharashtra State last year. Our book on Nobel Prizes in astronomy has been published by Stranger Nature. We are really privileged, madam, to have you amongst us, and you were so kind in sparing your valuable time for our young children. Will definitely be inspired to emulate your path as a scientist of repute. So with these words, on behalf of the University Outreach Cell, I again welcome you to this university and to a lecture. So today's topic is understanding the. Thank you very much. I welcome you again, madam. The platform is all yours.
Thank you.
Thank you very much.
Thank you. So shall I start?
Please.
Okay, so good afternoon, everybody. I am very happy to talk to you. I see lots of girls here. Most of them, I mean, at least most of the audience here is girls. So I'm more happy because of that. And anyway, I'm asked to talk about my journey so far, which I think is not that interesting. I would like to spend more time on the understanding the universe, the topic about in which I have done some work. So anyway, so let me tell you a little bit about myself. I was born and brought up in Indore, which is in Madhya Pradesh. It's not a particularly very big, at that time definitely it was not a very big town, and I was born in a typical middle class family who valued education very much. My parents, we were three sisters and one brother, and all of us were encouraged to study. And I will just tell you, my elder sister was a medical doctor. Then the next sister was did her economics post graduation, and then my father encouraged me to do physics, because at that time the nuclear energy program India's nuclear energy program had just started, and it was very interesting. And so he encouraged me to do physics. So I did physics from a college in Indore itself, which is called Holkar Science. At that time, it was Holkar Science College. And then after MSc, I went to TIFR to do PhD. So PhD was a bit of a struggle for me. I did not have, I mean, it depends on a lot of things, PhD. So I had to struggle a lot for PhD. But anyway, ultimately, I I worked in astrophysics. I will tell you a little bit about what I worked in when I start my subject lecture. And then I got married and came to Bhubaneswar, where I think all of you are sitting. And Bhubaneswar again was there was a big struggle in Bhubaneswar because at that time astronomy, even I did not know about astronomy till I joined TIFR. When I was in MSc, I had no idea about astronomy. Astronomy was not very popular at that time. Then when I came to Bhubaneswar, there also there was no astronomy. Nobody was studying astronomy. There were no books in astronomy. There were no journals in astronomy at that time. This I'm talking about 1970s. 76, 77, 78, etc. So at that time there was no internet. You can't imagine now. I mean, all the young audience cannot imagine how we used to live without internet. But there was no internet, there was no email, so there was no way to contact anybody else except writing letters. And in Orissa, there was nobody who was working in astronomy. So I had I had a big problem how to continue research. I had no job also for quite some time. But then Professor Dev of Utkal University, he invited me to give talks on my thesis work. He was somehow interested in astronomy. He had gone abroad and he had met astronomers and all that. So he knew about astronomy. He was interested. So he called me and he asked me to give lectures in astronomy in Utkal University, physics department. And then so I started going to Utkal University. And then as a lucky break, there was a lady astronomer, Judith Perry. She was from Germany. She was working in Germany. So she had come to Utkal University because she knew Professor Dev and she gave some talks. And I talked to her. I was the only astrophysicist. Judith Perry was an astrophysicist. So I talked to her and it so happened that at the end of her, she visited for a few days only. But at the end of her stay, she offered me a postdoc in Germany, which I of course accepted. But by the time the paperwork was done, I had a young son. And then how to go to Germany? My husband was going to England. So how will I go to Germany? I have a small son, but my mother-in-law helped me very much. I asked her if she can come with me and to take care of the son, and she agreed. And so three of us went to Germany: myself, my mother-in-law, and my 3-month-old son. And then she used to take care of him when I went to the institute and so on. But it was a very nice stay. I could do some good work there. That work got published ultimately in a good journal. And then anyway, after that, I again came back to India, to Bhubaneswar. Again, the same problem came up because no job. Then I got actually an OPS job, Odisha Public Service Commission. I mean lecturership, but that was in some Golangir and all that, so which I did not join. Ultimately, after a lot of struggle, in 1983, I got a job in Utkal University. But still, the problem of doing research in astronomy remained because astronomy, there was no as I told you, there was no literature, no journals, nobody to talk to, no internet. So it was very difficult for me to do research. But luckily, again, another lucky break is IUCA. I don't know if you have heard of the institute IUCA, Inter-University Center for Astronomy and Astrophysics. That is in Pune. So that came up, and they had I mean that institute was meant for people like me who used to work in universities who have no facilities for astronomy. So we could go and visit that IUCA for 1 month, 2 months, whatever we wanted, and then there all facilities were there. Slowly internet also came up, and then life became little easier. So then I got some other lucky break and I could pick up my research. Ultimately, I could pick up my research. I could do some good work. I got some very good PhD student. One very good PhD student. He came all the way from Tamil Nadu. I had a DST project in which I had advertised for a student. So this student, his name is R. Shri Anand. He came all the way from Tamil Nadu to Utkal University. It was so difficult for him because he was a vegetarian and the hostel condition in Utkal University was not particularly great. But anyway, we did some good work and he continued to do good work, and you will be happy to know that he is the director of IUCA now. So he progressed so much and did such good work that he is the director of IUCA. So that is the way. But all till internet came up, till Ayuka came up, I had to do a lot of struggle. But only thing I can say in my favor is I did not give up. I continued to struggle, and I kept up my efforts to do good research in astronomy, and finally, I think I succeeded. That is, I got recognition also. And then later on, I did. I was very much interested in science, astronomy popularization. So I have given a large number of lectures in schools and colleges, all over the country. Not only Orissa, not only Bhubaneswar, but all over the country. So that, and also in many times I have even given talks in Oriya in some school, Odisha school, and I have given talks in Hindi, and I of course have given many talks in Marathi after I shifted to Pune. So I like popularization of I like giving talks for popularization of astronomy very much, and I have also written books which are more or less popular science books. But in, for example, the Nobel Prize in Astronomy book. What that book does is, I have in that book, what I have tried to do is I have tried to explain the Nobel Prize winning work all in astronomy only. It is same as physics. I mean, the award is given in the category of physics, Nobel Prize in physics. But for 11 years, 11 times the award was given to astronomers. And that work I have tried to explain in very simple terms without using any equation, without using any mathematics, no mathematics at all. So I tried to explain it using basic physics concept. So that all people like you who are in colleges or even plus two students of plus two also can understand what is the work which is done by Nobel Prize winners. So that is the book I have written. That was my last book, and if you are interested, you can read and see if you understand the Nobel Prize winning work. Okay, so I think I can. That is enough about myself. I can now better concentrate on the more interesting topic, which is understanding the universe. Because I was told that I should talk about what work I have done. Now, what work I have done is going to be very difficult to tell. So I'm just going to give you basic idea about what type of work I have done during my career or during the later part of my career. Okay, so let me go to slides. Understanding the universe. I mean, that is the aim of all astronomers. Whatever astronomers do, that is the aim is to understand the universe. So let us start with what is meant by universe. Okay, so universe means whatever, everything that exists, everything around you, everything that you see in the night sky, everything, space, matter, radiation, everything together forms the universe. Entire space around us and all matter, all energy, and so on. But of course, we are going to talk about the heavenly objects. In this talk, we are going to talk about heavenly objects: Earth, Moon, planets, sun, stars, galaxies, energy, etc. So mostly I will be talking of galaxies, as I will show you. Very soon we will come to that. Now, understanding the universe, that is the topic of my talk. So what does it mean exactly? What do we want to understand about the universe? So there are a few things I have written down which we would like to get answers to. For example, first is we would like to understand what is the universe made up of. That means what all things does it contain? That is the first question to which we would like to get the answer. The second question for which we would like to get the answer was, how was the universe created? Was it created like what we are seeing it now, or it was created in a different state? The third question that we would like to answer, like to get answer to, is how did the universe evolve? If it was created in a different state, then how its properties changed with time so that now it came to the present stage. Now it looks like what we see it around us. And of course, The last question, you people can probably guess what is going to be the last question. Uh, I don't know whether you if you speak, I can hear you or not. I'm not sure. So I will not ask you questions. So the last thing we would like to know is what is going to happen to it in future. So my work actually basically it involved the first, what is it made up of, and how it evolved to come to the present stage. So it was, and of course it will involve a little bit of how it was created also. So these are the questions which I tried to answer in my research, and I'm going to tell you a little bit about that. So how do we get answers to all these questions? How do astronomers go about getting answers to these questions? Because how? So through observations of heavenly objects. Now, one thing you have to understand here is that astronomers' way of working is very different from way of working of physicists or chemists or biologists. Because physics, you already must be studying physics, chemistry, biology, and so on. And what do you do in that? When you study physics, chemistry, biology, you do experiments, right? You go to the lab and you do experiments. For example, if you want to, you are in, when you go to lab, you are given, in chemistry lab, you are given some powder and you are asked to find out what material does it contain, what chemicals it contains. So you do some experiment with that powder and you find out which elements it contains and so on. Or in physics, if you are given some object, if you are given some object, even for example like a computer mouse, then you want to know how it works. So you can always break it open or pull it apart and find out, see what is there inside and how it must be working and so on. But that option is not available for astronomers. If astronomers want to understand what sun is made up of, so we cannot go to the sun and bring some material from sun to our laboratory and study. That option is not there with us. Sun is first of all too far and it is also too hot. We cannot reach the sun at all. We have hardly reached the moon so far. So that option is not there. So what astronomers have to do is just sit here on the earth and observe the stars. That is the only option that we have. So that option, okay. Observing means collecting and studying light and through telescopes. Okay, we use telescopes so that we can gather a lot of light from these objects and then we study that light. That is the only thing in our hands, and you will be surprised that just by doing that we have obtained so much information about the universe. Okay, so I will remind you what is light. Light means radiation. We also call it radiation or a type of wave. Light is called electromagnetic wave. A wave has some characteristic wave. A picture you must have seen, right? In somewhere or the other, you must have seen a picture of wave. So some quantity increases and decreases in a wave. Okay, but this side is shown either distance or time, and on the y-axis is plotted the value of the quantity which varies in a wave. So in electromagnetic, in for example, water wave, it is the height of the water particle which goes up and increases and decreases. In electromagnetic wave, it is the value of electric field or magnetic field which increases or decreases. But that doesn't matter much. It won't bother us. But this length is called the wavelength of the radiation or wave, electromagnetic wave. The wavelength can be small wavelength. We can have electromagnetic waves with small wavelength or electromagnetic waves with large wavelength. And we all know that the light that we see is made up of 7 colors. And what is the difference in these 7 colors? All of them are electromagnetic waves, but the wavelength of red light is the largest, wavelength of violet light is the smallest. So these different colors are electromagnetic waves with different wavelengths. And there are other very small wavelengths. Electromagnetic radiation is called gamma rays. It's very powerful. Then little larger wavelength. We call them X-rays. Then comes ultraviolet.
Madam, this sharing is probably interrupted. We are able to see you and not the PPT.
Oh, But it is share is coming. I mean, I don't
I
know
think
why.
once again you click on the share button.
Share button is already muted, means there is nothing I cannot click. But stop sharing, I will do and again share. Let me try.
Uh,
It is not. I cannot do. I will have to come out and then see what can be done.
yes, please, madam.
Because the share button is, I cannot do anything to share button. It is not active any longer. Unshare, I mean, there is no stop sharing button is not there. So I have no idea what to do. It was working, right? When did it stop working?
Few minutes back. Just few minutes back, I think.
The share button is not active. I cannot do anything about it. Maybe I will have to start again.
Yes, madam. Otherwise, you can log out now.
So I will leave the meeting and join again. Okay.
Yes, ma'am. Yes.
असं मला silent करते. You can't see? Hello?
Now I am able to
Hello?
see you. Yes, I am able to see you. Professor Priyambada madam is also here. Madam, namaskar.
Yeah, but
Namaskar.
you are not able to see me.
No, I am able to see you, madam. I am able to see you.
You are
But
able to
not
see me, but not the slides, no. But
not the slide.
but the share button is not active. What can I do?
Or can you send the mail the slides to me?
Professor Nachikata, can you hear me?
Yes, ma'am. Yes. Namaste, ma'am.
Okay. Then I am all set. Thank you.
Okay, ma'am.
Thank you. Oh, thank you.
The share button is not working on it doesn't. I don't know how to do what to do. I have no idea.
Uh,
Sir, may I suggest you mail the presentation to Nachiketa ji and let
yes,
him do.
yes.
That.
Please mail
Okay.
it. Uh,
Okay.
uh,
But I should be able to see that also. I will mail it just now.
you will
Yeah.
see it. Please mail it. Uh,
What is your mail address?
uh, so should I send it to WhatsApp or I will just
No, I will send by email. So what is it? Tell me, just tell me. It will come automatically. You tell me the beginning.
uh, director
Director UOP.
yes dot uop director dot uop
Director.UOP. Yeah.
at
Okay.
soa.ac.in
Yeah. Okay, I have sent.
okay then it will have
Have you got?
Just wait, madam. I am.
And you show it to me also so that I will know what I'm talking about.
Yes, yes, yes. It will be shown to you, madam. 1 minute, 1 minute.
You got it, no?
Yes, yes, I have got it. Again.
Hello, Priyambada, how are you?
Oh, hello, Pushpa. Can you hear me?
Yes, yes.
Hello.
I
Nice
can
to see
hear you.
you.
I can see you.
Nice to see you after so many years.
I know.
Yeah, it's nice that Nachiketa professor has brought us together.
I
Okay.
know.
Thank you, ma'am.
Yeah.
Thank you. Thank you so much.
Looking forward to hearing your lecture. Where are
Yeah.
you now? Where are you?
I am in
Where is
Pune. Pune.
Yeah.
Okay. Wonderful. We are going
Okay.
back to
Are
our.
you are you are you able to see it, madam?
Yes, I'm able to see.
Okay, okay. Once you say,
So
I can go one after another.
yeah, you can do slideshow, no?
Yes.
Okay. So you can do click and go to the next page because I click on every single line. You can keep clicking and go to the this is all done. So I will tell you next and then you have to do next. This is all done also. This is done. Okay, so this is where we were. So we have electromagnetic radiation in different wavelengths, which we divide into 7 parts. Gamma rays, X-rays, ultraviolet, visible light. Visible light is light which of 7 colors, which we can see. And then comes infrared, microwave, and radio waves. Next. Next.
Okay, madam. Just.
Can you click on that, please? Huh?
Uh,
Okay. So optical and radio telescope can be ground based because optical and radiation can travel through Earth's atmosphere and reach the ground. But gamma ray, X-ray, ultraviolet, infrared telescopes have to be put above the Earth's atmosphere because all these gamma ray, X-ray, ultraviolet, infrared, microwave, they all get absorbed in the Earth's atmosphere. So if we want to observe the gamma rays coming from some source, cosmic source, then we have to take our instruments and put them above the Earth's atmosphere. And just by studying this radiation, we have understood so many things about the universe. For example, we can measure the sizes of stars, their masses, their temperature, their distances, what they are made up of, their velocity with respect to us, and so on. So we have got enough knowledge about. Okay. So here is one thing which I want to show. These are clouds, but these are not clouds in our sky that we see. These are clouds in space in between stars, which are called interstellar space in between stars. And these clouds are made up of gas, and there is also some dust particles in it. And you know that the light moon is very far from us. So the light from moon takes 1 second to reach Earth. The light from the sun is much farther. So light from the sun takes 8 minutes to reach us. But these clouds are so huge that if light starts from one end to go to the other end, it may take 10 or 20 years. And that distance traveled by light in 1 year is called a light year. That is the measure of distance. So there are huge clouds, and from these clouds, stars form, and then these are basically the place where the stars form. Okay, next. Next. Okay. So now this picture, I will tell you a little bit about what is this picture. This is called Hubble Ultra Deep Field. So one thing you should understand about Hubble telescope, you probably have seen some small telescope somewhere or the other, and you might have seen some stars from through the telescopes, or at least you might have seen the moon and the Saturn and so on. So one thing you know is that we can use telescopes and we can see the stars only at night, because daytime sunlight is there and we cannot see the stars. But if you are using Hubble Space Telescope or now James Webb Telescope, which is kept much above Earth's atmosphere, then for Hubble Space Telescope, the sky always looks dark. Always. There is no daytime or there is no night time. Unless if the Hubble Space Telescope is looking towards the sun, then only it will see bright light. Otherwise, all the rest of the portion of the sky is black always. So what this Hubble Space Telescope did was they chose a small portion of sky as big as that of moon area of the moon that we see. That much big portion of the sky, the Hubble Space Telescope observed continuously for more than 10 days. And then this is, I mean, they took a very long exposure, 10 days or 12 days long exposure of a very small portion of sky where they could not see anything with ordinary telescopes. It was all looking very dark. But when they observed it for so many days together, then they saw this picture. And in this picture, every dot that you see is a galaxy. Okay, every dot that you see is a galaxy. So we can say, by looking at this picture, we can say that galaxies are the building blocks of universe. Universe is made up of different galaxies put together. Okay, next. Next. So these are more. You can click more 2 times. So there are different types of galaxies. This is one galaxy that is shown here. That this is called a spiral galaxy because these are spiral arms. And in
Madam, we are not able to see you.
I can see, but I cannot hear you.
Same here. I can see Pushpa, but can't hear her.
Nachiketa, can you unmute her from your end?
Unmute.
Can't hear.
Like Madam, you have to unmute yourself. This side it's okay.
Okay, now.
Yes.
Yes,
now,
yes.
now you are audible.
Okay, but I did not do anything. I don't know how it happened. Anyway, so next.
Next.
Next. Okay, so there are different types of galaxies. One was spiral galaxy, another is elliptical galaxy. Elliptical galaxy is like a spheroid, and irregular galaxies. And a galaxy, typical galaxy may contain 10 to the power 11 stars. Next. Okay. Number of galaxies in the observable universe. You can keep pressing till you come to the end of this. Okay, that's one more. So this number of galaxies in the observable universe is roughly 10 to the power 11. That is just an estimate. And the sizes I can tell you. The size of a man is 1.5 meters. Size of the earth is roughly 10 to the power 4 kilometers. Size of the sun is 10 to the power 6 kilometers. Distance between earth and sun is 10 to the power 8 kilometers. Size of a typical galaxy is of the order of 10 to the power 18 kilometers. Distance between two galaxies is 10 to the power 19 kilometers. And size of the observable universe. Universe may be infinite in size, but the maximum distance up to which we can observe is 10 to the power 23 kilometers. Now, why that is so, you can think about it later on. Okay, next. Now, this is the most interesting thing, picture. If you understand this, then you will understand the rest of the talk. So, what I have drawn here are all these circles are galaxies. Okay, each circle is a galaxy. And let us assume that all galaxies in the universe are exactly same in size and same color. Just let us assume that. Okay, I showed you just now 3 galaxies which are different, but let us assume all galaxies are same size and same color. Then why have I drawn? And this blue thing is our galaxy, Milky Way. We are sitting here and observing the galaxies around us. Now, obviously, these green galaxies are a little far away from us, so they will look smaller to us. Yellow galaxies are even farther away from us, so they will look even smaller. Red galaxies are still further, they will look even smaller. So that is understood, that the farther they are, they will look smaller. Anything that is far looks smaller. But why is their color different? Why their color changes? That changes because of some effect which is known as Doppler effect. So the light, these galaxies are all, this is the conclusion drawn from all these observations. What arrows show the velocity of the galaxies. Velocity of the direction of velocity, and the size of the arrow shows their magnitude of the velocity. So you will notice that green galaxy, first of all, you will notice that all galaxies are going away from us, away from the Milky Way. And second thing you will notice is the green galaxies which are nearer to us are having small velocity. Yellow, which are farther than us, are having larger velocity. And these are even further, they are having even larger velocity. So this was discovered by Hubble, and what he concluded was all galaxies are going away from us, and farther a galaxy is, larger is its velocity of going away from us. Now, how do you explain this? How can one explain this phenomenon? Why are all galaxies going away from us? So are we in a special place? So the answer is no, we cannot be in a special place, or our galaxy is not, there is nothing special about our galaxy. So, because, for example, earlier we thought, long back, we thought that Earth is the center of the universe, which turned out to be wrong. Then we thought that solar system, sun is the center of the universe, which was wrong. So our Milky Way cannot be at the center of the universe. In any galaxy, suppose I was sitting on this galaxy and I observe galaxies around me, I will see exactly the same picture. I will see that all galaxies are going away from me, and farther a galaxy is, faster it is going away from me. Next, please. Okay, so this can be understood before that. Okay, this can be understood from this figure. So suppose we have a balloon and we have some dots printed on the balloon, and we blow the balloon. Now every dot will go away from every other dot, right? Why? Because the rubber is getting stretched. So the rubber between 2 points is getting stretched, so the 2 points are going away from each other. The farther the 2 points are, the faster they will go away from each other, because there is more rubber. So that more rubber will get stretched. If I take this and this dot, they will go away faster than each other as compared to this dot and this dot, because they are nearer. So exactly this is happening in the universe. Next. So what is happening is, the universe, all the galaxies are going away from one another, and we can now conclude that because right now all the galaxies are going with this speed, earlier times they were closer and closer and closer and closer to each other, right? When there was no air in the balloon, all the dots were at one point. Exactly like that, in the universe, in the beginning of the universe, all galaxies were concentrated at one point only. And that point, some explosion occurred, and that explosion is called Big Bang explosion, and the theory is called Big Bang theory. So I will just tell you the conclusions of this theory. So we have concluded, scientists have concluded that the universe was created 13.7 billion years back. When it was created, it was extremely hot and dense, because all this material which is there in the galaxies, everything was contained in one point. So the density was very large and the temperature was very high. Then slowly, as the universe expanded because of this explosion, it cooled and the temperature decreased, density decreased. So initially the universe contained only radiation and elementary particles. By elementary particles, I mean the proton, neutron, electron, or even quarks, if you have heard of them. So then when it slowly cooled down, then quarks combined to give protons, protons combined with other proton, and the nuclear reactions took place. So for less than 200 seconds, nuclear reactions took place. And at that time, which elements formed? The deuterium, helium, lithium, beryllium, boron. And this is called Big Bang nucleosynthesis. Nucleosynthesis means generation of elements through at the time of Big Bang. And then slowly galaxies formed and stars formed. And inside stars, then the rest of the heavier elements formed. All the elements that we see around us, iron, magnesium, calcium, gold, and so on and so forth, they were all formed inside stars. And when the stars exploded, that material came out and mixed with the interstellar clouds. Okay, next, please. Now I cannot, before, I cannot unfortunately tell you in detail. I mean, I'm sure you will find all these concepts difficult to understand. In such a short time, it is not possible to tell you in more details. So how do we prove that this theory is correct? This Big Bang theory is correct. How do we know? So one way, I'm just going to tell you about one way to prove that this theory is correct is by showing. So initially there were no heavy elements. Initially everything was elementary particles. Then slowly, in the first 20 minutes in the life of the universe, the elements, light elements, that is deuterium, helium, beryllium, boron, they formed that in the first 20 minutes. And then the rest of the elements formed in stars. And they come out, these elements which form inside stars, when the stars explode, they come out, they mix with the interstellar gas. So when the new stars form, they will already have some heavy elements. And then more heavy elements will be created in these stars. When they explode, those heavy elements will all mix again with the interstellar gas, and the next generation of stars will have even higher abundance of heavy elements. So this process, if we can prove that with time, the abundance of heavy elements, like take magnesium for example, and carbon for example. So if we see very old galaxies, then the amount of carbon and magnesium they have must be very little. If we see young galaxies, the amount of magnesium and carbon that they have must be higher, because the abundance keeps on increasing with time. And how do we measure ages of galaxies? By using Hubble's theory. Next, please. Okay, so now I will tell you, suppose these three are galaxies. Okay, they are at different distances from us. Now light will take some time to come from light which starts. Okay, let us say that we are looking at all these galaxies today. So the light that we are receiving today started from these galaxies. For example, here I have given. It might have started 8 giga years back to come to us. The light from this galaxy, it is farther, so the light must have started even earlier. Maybe it started 11 giga years back. Light from this galaxy, which is even farther, must have started 12 giga years back. That means we are observing, and if all the galaxies were created at the same time, then we are observing these galaxies when they were at different times of in the evolution, in their lifetime. For example, this galaxy we are seeing as it was only 8 giga years back. This we are seeing as it was 11 giga years back, and this we are seeing as it was 12 giga years back. So if we observe how much carbon is there in this galaxy, how much carbon is there in this galaxy, how much carbon is there in this galaxy, then what should we find? That this galaxy should have least amount of carbon. This galaxy should have little bit more carbon, and this galaxy should have the highest amount of carbon out of all these three. So that is what we try to do. In my research, one of the things in my research that I tried to do was measure the abundances of heavy elements in galaxies at different distances from us, and therefore galaxies at different ages, and galaxies at different ages during their lifetime. Next, please. Okay. So how do we do that? back, please. So this is a spectrum of a galaxy or a spectrum of anyway. This is actually the spectrum of a quasar, but and the black lines here are called absorption lines because they are produced by they could be produced by carbon, they could be produced by magnesium. We can identify which line is produced by carbon, for example. So we take spectrum of all galaxies. We can measure the abundance of carbon from the absorption line. So we measured the abundance of carbon from and magnesium and silicon and so on of from for different galaxies which are at different distances from us. Okay. So next, please. So using big telescopes all over the world, we have shown that the amount of chemical elements in the galaxies is increasing with time. So we have indeed proved, we have measured the chemical abundances of elements in different galaxies when their ages were different. And we showed that as the age of a galaxy increases, as the age of a galaxy increases, the also increases. So it is consistent with the Big Bang theory. So in that way, we supplied some proof for the Big Bang theory. This is just one aspect of what I did in my research. So I think I will stop here because I cannot, one cannot go on talking about everything. So I will stop here and I will be very happy if you want to ask any questions.
Madam. Thank you, madam. Thank you. So we'll take few of the questions. That. Do you like to ask question? Anybody? Yes, please ask.
Very good evening, ma'am. It was a nice session and it's nice to meet you. As you said that astronomy was not that popular at that time, so why did you choose astronomy rather than choosing any other stream which was in physics like atomic theory physics or like that, ma'am?
So there are some constraints. I mean, there are that group, particular group like atomic physics, you said, that has to have a vacancy for taking a student. Okay. So there are, one cannot choose whatever one wants. I mean, whichever subject one wants. So there were constraints and there was choice was between astrophysics, which was mostly theoretical, and some experimental physics. So I chose, I prefer theory. I am not particularly interested in experiments. So I chose theory and therefore I chose astronomy.
Ma'am.
Yes.
Good evening, madam. Good evening, madam. I was enjoying listening to you. Like, I have a question. Like, in one of your slides, you have mentioned the universe is expanding. I mean, so if the universe keeps on expanding, so what will be the consequences or what will be the outcomes? So that was my
Yeah.
question.
Yeah, okay, good question. So universe is expanding is has been proved. I mean, has been seen from observations. Now, what will be the future of the universe? We need more information about a lot of things to understand what is going to be the future of the universe. So right now, for example, I will just tell you, if we throw a ball up, okay, on the surface of the Earth, we know that its velocity keeps decreasing because Earth is attracting it with gravitational force, and after some time it may stop or come down, or that depends on the initial velocity that we have given it, right? If the velocity is larger than escape velocity, then the ball will just escape the Earth's gravitational force and go away. If it is less, it will fall down. So exactly like that, universe is expanding because of the initial expansion, initial explosion. That gave it the velocity of expansion. But now there is so much matter in the universe. There are so many galaxies and so much, so that all the galaxies are attracting each other because of gravitational force. So the gravitational force is opposing the expansion of the universe. And which one wins? will depend on how much gravitation, how much matter is there in the universe, whether the gravitational force of all the matter in the universe can overcome the expansion velocity and pull it back again. It depends on that, and we, from whatever observations we know we have so far, the conclusion right now is the universe will go on expanding forever, because recently we have come to recently means last 20 years or more than 30 years, that the universe is not only expanding, it is accelerating. Its expansion rate is increasing, and that is, people have not understood. They have just put a hypothesis that there is some energy called dark energy which is making that, which is pushing the galaxies away from each other. So what is that force, or what is that dark energy, nobody knows. But from our observations, we believe that the universe will go on getting accelerated and go on expanding forever.
Okay, thank you, madam. Thank you.
Thank you,
Um,
madam, for the nice talk. Madam,
Professor Khare
the
and
mass of the
Professor
universe,
Hedgman,
is it a constant?
this is Shubhankar from the Academy Trust, and I wanted to thank you so much on behalf of the Academy Trust as well as Women in Science of the Indian Academy of Sciences for participating in this. I hope we will be able to keep, just like the universe is accelerating, we hope that we will be able to accelerate our outreach programs and bring in more to the fold. Can you, ma'am, can you give a brief, very brief idea that, just because the James Webb telescope is up and all that, that there is still a lot of things, research that is to be done yet. So if you could say a few words to these young people, it would, we could hope to inspire some of these people to take up research in these areas.
Yeah, yeah. I mean, especially this is the best time to do astronomy, because there are so many big facilities which are coming up. James Webb, you see in the newspaper every day there is some news from some new information from James Webb telescope. Then there is you must have heard the last thing, latest thing which happened, which revolutionized astronomy. That happened in 2016, was the detection of gravitational waves. Have you heard of gravitational waves? Gravitational waves are very different from electromagnetic waves. Electromagnetic waves, gravitational waves, with gravitational waves, we can see that part of the universe which we cannot see with electromagnetic waves. For example, if you have heard of black holes cannot be observed with electromagnetic. They do not emit any electromagnetic radiation, but they do emit gravitational waves. And gravitational waves are very, very, very difficult to detect, but they have made it has been successful. I mean, human beings have been successful in building detectors, and we have observed gravitational waves. And there are some few detectors in the world, but another detector is coming up in India, in Maharashtra, and that is the third. They are called LIGO. There are two LIGO detectors: laser interferometric gravitational wave observatory. So two of them exist in America, and the third one is coming in India. So that is a big opportunity for Indian astronomers to work. Then there is one, there are many, many other things. GMRT, if you have heard, Giant Meter Wave Radio Telescope, that is again near Pune. And that is a world-class facility, completely built in India, made in India, and world-class facility. People from 30 countries come every year to take observations with GMRT. So that is available. And now another even bigger telescope is being constructed, which is called a Square Kilometer Array. That is a radio telescope. Many countries together they are building up, and India is also part of that. So there are for Indian astronomers, there are lots and lots of facilities which are opportunities which are coming up in very soon. They are under construction now. So this is a very interesting area of research, and lot of opportunities for students to work in that.
So, Nachiketa ji, I would like to whether there's this science academies, the three science academies of India. We have this science summer research fellowship program. Right now, it is happening, and every year around 2,500 students from all over India, from the remotest corners of India, participate as they go to they go and work with professors like Professor Khare and Hejmadi. They go to their labs, work with them for 2 months. We facilitate that. So you can encourage your students to look up the Indian Academy of Sciences website, and if they are interested in the internship program, whatever subjects they are interested in, they can come and work with these great professors who have this immense wealth of knowledge. And this, it's a 2 month summer fellowship program. So right now this year's is already happening, half of it is almost over, but this coming years they can definitely participate in this, which is very, very rewarding, because opportunities open up a huge lot for the students who are interested in in these, in their subjects.
Dr. Nachiketa, can I share some of my experience?
Yes, yes.
Please do,
Hello.
ma'am.
Yeah, Puspa, I would like to share something with you. Being a student of University of Michigan, well, PhD in zoology was something else, but it gave me an opportunity to hear larger than life people from Muhammad Ali to even Subramaniam Chandrasekhar talk about dark holes. One of the things the University of Michigan did, when these people come to give lectures, the public comes. So they have TV all outside. There is so much interest. And I went about an hour before the lecture started because it gets packed. And one who had already gotten the Nobel Prize for his work on moon, Harold Urey, was there, and Dr. Chandrasekhar was there. This was in the wave of when black hole concept was coming. Kids were coming out with T-shirts with the black holes. They thought it is real cool. So Dr. Chandrasekhar gave a very, very interesting lecture. You have seen him. He's very serious person, very tall and very, imposing personality, but very, very low key and very, very gentle.
Soft spoken.
So when
Very good.
when the questions came up, one kid got up and said, the Big Bang happened, okay, but why did it happen? So Dr. Chandrasekhar just, he took, a sort of a while, became very quiet, and in his voice said, well, this has come up in many of the conferences we have been together, and, we have had arguments and all that. And we have all agreed on one point. And listen to me to what he said. It happened because it had to happen. As the whole audience burst into laughter for minutes because nobody expected Chandrasekhar to come out with this. And besides, such a succinct, thing to the way to answer. Then Harold Urey comes next. He says, "You see, my friend Chandrasekhar's name is the bearer of the moon, and Harold Urey had worked on the moon." And he has no interest in the moon. So I don't know why I have been put together with him. So these are experiences I thought I'll share. That even the Nobel Prize winners have a great sense of humor. Thank you very much.
Can't hear. We cannot hear.
Nachiketa,
Can't hear my. I, I don't know if you heard
Oh,
me.
yes, yes.
Now
Thank
we
you,
could
ma'am.
hear
Thank
you.
you.
I
Thank
could hear
you.
you.
Yes, yes. Thank you, ma'am.
But
Thank
what I
you.
said about Chandrasekhar.
Uh,
Yeah,
Now,
yeah.
Puspa ma'am, can you give another 5 minutes, or we should stop here because there are one or two questions. There are more
Okay.
questions in the,
Okay, okay.
Okay,
Fine,
ma'am.
fine,
So,
no problem.
okay, so Professor Rao, please.
Thank you, madam.
Yes, yes, I can hear you.
The total mass of the universe, is it a constant?
Total mass of the universe means mass of energy plus matter is a constant. No new matter is being created.
There is another question, madam, not related to.
Can't hear.
yeah,
I can't
you have
hear.
gone mute, then Nachiketa,
Yes,
you have,
yes.
yeah.
Yes. Now, so there is a question not related to physics, but this is very important. Silky Saloni has asked, Madam, please say something about the role of your mother-in-law in your career.
I already told you. It was very, very important. My mother-in-law played a very important role because when I was in Utkal University, I was not able to do research. And then, as I told you, that I got a chance to go for postdoc to Germany. And I had, by that time, I had a 3-month-old son. And my mother-in-law agreed to come with me. She took care of the son. And so I could do some good work there in Germany. I could do good research. And that it's in fact that research as a topic was what I continued to work throughout my career later on. So my mother-in-law, I give all credit for my able to for my being able to do research.
Thank you, ma'am. We'll take probably another one last questions because the other two questions you have already answered. How are you manage your research work at Utkal University as only one astronomer in the entire state of Odisha? And since astronomy is not popular at that time, why you chose astronomy for your career instead of choosing atomic something?
Hmm.
So I think we should atomic or atomic energy physics. I think you have already almost applied this answered these questions. Rather, we will take the other question by Abhishek Patnaik. What role does exploration play in expanding our knowledge of the universe and our place within it? And what actions can we take on a personal level to contribute to a more understanding and connected world?
What space exploration?
What role does space exploration play in expanding
Mhm.
our knowledge of the universe and our place within it? And what actions can we take on a personal level to contribute to a more understanding of a connected world? Uh,
So space exploration is exactly what he meant by means human being going to space or space exploration through instruments which we are already doing. A lot of telescopes, as I said, have been built, and bigger telescopes are continuing to be built. So that is definitely increasing our knowledge. As you even if you read newspaper, you will see that James Webb Telescope itself is giving so much new information every day, and this gravitational wave observatory is also coming up with so many new things about black holes and so on. So our knowledge of universe is definitely going up every day, and it is going to go up even more because of all the big facilities which are coming into picture. And if you talk about space exploration by human beings, that is only limited so far up to moon, and that is going to again increase because of many countries are thinking of sending human beings to the moon. And definitely we need all the information we can gather to understand our place in the universe, or how the universe, as she said, Chandrasekhar said that it had to happen, but why had it to, I mean, why did it have to happen? That nobody knows the answer to. So there are many unanswered questions which we have to find answers to. So space exploration is very, very necessary.
And if
Ma'am.
you don't
Thank
mind,
you.
I would like to add, Nachiketa, the student's question has a very deep, it's very
Yes, yes,
meaningful. I
yes.
appreciate this question because
Yes, it will have
now
an
in
the
this,
space exploration will have an humbling experience. Yes, yes, yes.
not only that, see, this is
Uh,
the beauty of space exploration by human beings, that no single country can ever make a big success unless we all get together. As the professor was saying, for us to discover all across the on all continents, Australia, South America, North America, Asia, all continents have contributed by triangulating our observatories, our telescopes, and all. The data that is coming in is studied. Scientists don't have any country, they don't have any nationality. Artists, scientists, these are people who are Vishwamanava. We are, C.V. Raman used to say that I'm a Vishwamanava, and this is exactly what he meant. That we don't have nationalities. Scientists, and this is the beauty that this young generation also they have friends all over the world. Unlike the pre-internet days that professor was victim to, now these people are they have friends all across the world, and which is a beautiful thing, because we need cooperation from every human being on this world. No gender, no race, no caste, no country should ever come in between, because only cooperation leads to great technological and advancement in science. And this ISS, the International Space Station, just imagine how many countries, without that we couldn't have done this much space exploration. So space exploration brings humanity together, which is a very beautiful thing to happen. you know so I
thank
appreciate
you.
this question very much.
Thank you, Subhankarji. Thank you. Now, because the academy is our official partner as far as this SOAFAL is concerned, and I am extremely thankful to you that you have participated throughout the program, and the presence of Madam Priyambata ji has added value to this whole SOAFAL oration.
Yes, yes.
On behalf of the university, I am extremely thankful and grateful to today's speaker. And let me announce that on 8th June, we have Professor Prajwal Sastri's talk on the meandering into astrophysics. So we'll have two back-to-back astrophysics lecture. So I'm on behalf of the university, outreach cell, and the academic trust. We are so much grateful and thankful to today's speaker, and also Madam Madiji and Shubhankarji. With these words, once again, on behalf of the students, lady students, and the entire university, we are extremely grateful to you. Thank you so much. Thank you.
Thank you.
Thank you
Thank
very
you so
much.
much. Thank you.
Okay. Bye.
Bye, Pushpa.
Bye.
Nice seeing you.
Yeah, I know. Okay. I'm leaving.